Okay, so the formula for the force in vector form, F2 is equals to minus F1 is equals to Q1, Q2 over 4 pi epsilon naught r squared times the unit vector AR. So the first thing you want to solve is to work out the vector R. The vector R is equals to vector R2 minus vector R1. It is 2, 1, 0 minus 1, 0, 1. That gives us 1, 1, minus 1. And the unit vector R, repeat my vector R over its magnitude. That will be, so this is in millimeter. This will be √3. So top is in millimeter, bottom is also millimeter. Therefore, this is simply equals to 1, 1 minus 1 over √3. Okay, so next you find the force. F2 is equals to minus F1 is equals to Q1, Q2 over 4 pi epsilon naught r squared times our unit vector R. That will be 20 nanocoulombs. Nano is 10 to the power 9 minus 9 times 5 nano over 4 pi is 8.854 times 10 to the minus 12 times r squared. So our R is the magnitude, which is √3 in millimeters. Thing squared times our unit vector, which is 1, 1 minus 1 over √3. Okay, so you have to be careful here. So here is in millimeter, but here is not in millimeter because top is millimeter, bottom millimeter, this cancel out. Okay, so if you put this sum into your calculator, you should get 0.173, 1, 1 minus 1. Or you can write it as 0.173, 0.173 minus 0.173 Newton. Okay, so in other words, F1 equals to minus 0.173 minus 0.173, 0.173 Newton. F2 is, let's calculate, which is 0.173, 0.173 minus 0.173 Newton. This is Q2. So we always define the vector as 1 to 2 is my R. Okay, and then our force, F2, will be in the same direction as R. And F1 will be in the opposite direction of R. Therefore, we write our equations as F2 equals to minus F1, and that is a function of the unit vector R, to show that F2 and R is in the same direction. Okay, is that clear?
Sir?
Yes.
What will be in the bracket?
So the bracket will be that equation, which is Q1, Q2 over 4 pi epsilon naught R squared.
Thank you, sir.
Which is our formula here. Okay, so F2 and AR is in the same direction. F1 is in the opposite direction. The reasons why this is the case, because this is defined for Q1, Q2. So if Q1 and Q2 are both positive, then this force is in the same or in the correct direction. But if one of the force is negative, then it will automatically take care of the directions. So if F2 is negative, then if you put into the equations, F1 is a positive number, F2 is a negative number, and therefore F2 will now become a vector that in the opposite direction, because it's an attraction force. Okay, so this is if you put one of the charge is opposite polarity. Then because of the negative sign, if you put it into this equation, then it will automatically force this vector to be in the opposite direction.